very excited about this conversation. I hope you are at least half as excited as I am. Please give a round of applause for your next speaker, Carlos Kidman.
I made that a mouthful, and I apologize. I was like, damn, I guess even for me that was hard to listen to. But hello, everybody. Yes, so my name is Carlos Kidman. They already introduced me pretty darn well, so I'll just skip right past this slide and just jump right into what we're going to be talking about. So, let's say that we are the software engineering team for this grocery store chain. And what they want us to do is to predict how much customers would spend. That way we can do things like preventing understocking or overstocking, right? Something like milk or perishable foods. If I buy too much milk and I don't sell a lot of it, I gotta throw away the milk, I'm gonna lose a bunch of money. If I only buy 10 gallons and I run out of 10 gallons within the first day, I'm gonna lose a bunch of money because I don't have enough milk, right? So there might be a use case that we're testing for. This is the data that we have access to. We have the number of people. One person came in, they spent $10. Two people came in, they spent $20. Four people came in, spent $40. Fantastic. So my question to the audience is, how much do you think 3 people can spend? 30. How'd you come up with that number? It's so fast. Yeah, you saw this magical number of 10, and you may not have thought of it this way, but this number of 10 describes the relationship between the number of people and how much they actually spent. And then, in an algorithm that we call linear regression in mathematics, you determined that 30 is probably the best prediction. Now, you probably didn't think of it that way, right? You're like, no, that's 30, pretty obvious, right? But this is exactly what machine learning does. So there you go, round of applause, you're all machine learning engineers already. Ask for a raise, get the promotion. Fantastic, fantastic. Now, is it guaranteed that 3 people will spend $30? Right? They might come in, they might just go take a poop real quick and then leave, they spend nothing. Right? They might just go buy like in Arizona and spend $1, that's how much it costs in Utah at least. They might buy a drink and it's $1, and then they leave. You have no idea. $29, $35, $40, you have no idea how much they're going to spend. It's just a prediction. That's what makes these things a little bit more difficult to test. So if we take a function like this, check that a number is even, return that quick division, and now we have a couple test cases. Test that 2 is even, should be true. Test that 3 is not even, should be false. And we can see that my test case failed, and I'm sure a lot of the developers look at that and go, well, obviously it's going to fail because then you found the problem. Right? Pretty straightforward. You know the inputs, you know the outputs, and you know the rules within it, so it becomes a lot easier. But if I ask this question of something like ChatGPT, and I say, is 2 an even number? Yes, 2 is an even number, and then it goes on. Is 3 an even number? No, 3 is not an even number, yada, 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 yada. Which one of these 2 answers is more correct? Any guesses? It's difficult to say, right? Like, they're both right. And given my very simple question, both answers are correct. But when you say which one is more correct, well, now we start getting into a subjective realm because, well, it depends, right? So that's why we're talking about this. So, real case scenario that happened in the real world. There was AI for the housing market. I'm not going to call it the company at all. But what they had was dozens, hundreds of analysts to basically go into the markets and see which properties can we buy really cheap. Let's do something to it, maybe even just wait or remodel or something like that. Let's sell it for more money and boom, profits. Right? Very simple. All the analysts were doing was finding patterns in these places. Okay, what are the neighborhoods like? What was it last year? They were finding these patterns in the data. So they thought, why can't we just use AI to do this ourselves? Because it finds patterns in relationships. Apply AI to it, the AI starts doing it very, very well. All their training and everything promises. It starts buying and selling 1,000 times the speed of a human. So eventually, they start letting go of their human analysts. What could go wrong? Well, things went very wrong. They ended up hemorrhaging millions of dollars and having to let go of over 50% of their entire workforce because of this problem that they had. So what do you think happened? Why? Everything looks great. What happened? What do you think? A little louder, please. Sorry. Not as easy. Overfitting, dangerous, hearing some things. Maybe some hot keywords you've heard in the past. All right, let's keep going. This person said, I sold my house to them last week for $550,000. And they just called to ask if I wanted to buy it back. I offered $350,000 and they accepted it on the spot. This man made $200K in the span of a week because the AI messed up. And imagine this at the scale of AI just going. You lost millions, right? So we learned a lot of things from this. Some of them are here, but the main ones are the blue and orange here. They were too dependent on the AI. The AI system was able to sell and purchase things at will. And when it was doing really great, awesome, well then let it go. And it started going, and just kept going and going and going. Risk of external factors, what was going on in 2021? The pandemic. Do you think the model was trained on a pandemic market? Of course not. And so there was that data drift. It was good at first. It was outperforming everyone, making them a bunch of money. You saw the chart where they're going up, right? They're making a bunch of money. It was good at first, and then it got worse over time. Until, I don't know why, I don't work there, right? But I don't know why they didn't just turn it off and be like, holy crap, we're losing a lot of money. It just kept going and going and going. So it may not take over the world in like Skynet style, but it could run you out of business. So let's take this to a more theoretical example here. Let's use AI for hiring talent. When I was at Adobe, if I posted a position for like software engineer, platform engineer, software tester, whatever the case, I would have easily 1,000 applications in the first 24 hours. It is impossible for a single human to go through that many applications. There's just no way. So what if instead I trained an AI to determine who are the best candidates, give me the top ones, so then I can focus on going through the best ones, right? Well, in order for me to do that, I need to have some sort of training data set. I need to tell it what I'm looking for. So I go, well, I work at Adobe. Adobe's awesome. So what if I get the top 10% performers, the best developers I have in my organization, and I need to determine, well, how do I make that like a data set? So, okay, I'm going to have hard skills, maybe soft skills. I'm going to try to find out how do I grade them, who's an A developer versus a D developer. I'm going to do all this research, all this work to do that. Finally, somehow, don't ask me how, but somehow I'm able to actually create this scorecard and determine my best developers. I get all the data, put it in something like a database, and then I visualize it. And this is the data that I have. Blue are men, pink are women. You have hard skills as your Y, you have soft skills as your X. So of course, my best performers are in the top white quadrant. What problems do you see with my data set? It's immediately biased. Now in this simple example, it's very obvious. It's super obvious, right? But if I have a petabyte of data, how the heck am I supposed to go through each row and determine that my data is biased or not? It's very difficult to. And yes, we have tools to help out with this, but I don't think anyone wants to try and do SQL queries to try to figure this out, right? There was a report done last year that said 21% represent women in tech, 92% are men. And that is, I would say, also true at Adobe. But immediately, my model is sexist. Immediately. Let's look at the same exact data, but this time maybe let's look at color. You got white people and anybody else with the other ones, right? So immediately, I also have a racist AI. And I did not go with the intention to make a sexist and racist AI. That my goal was just to make my job easier and find the best talent. But the data I had access to was already skewed. And unless I know to look for these things, all of these harmful biases make it into my AI. So, with that said, I was like, ooh, I know. But let's go into some actual techniques that we can use to actually test some of these things, to actually test the behaviors, because for data scientists, they're going to be looking at training and validation. What are my loss metrics? How accurate is it? They're looking at that. As a software tester, I don't really care. I care about, can it do the thing it's supposed to be doing, and can it do it well? Can it do it safely? Can it do it securely, right? So, adversarial attacks is going to be one of them. Let's check this out. I know it might be a little bit difficult to see, but this is a small video of a person who's moving a plastic turtle. And as they're moving it, what they're trying to see is that the AI can determine what the heck it's looking at. That red bar that you see, that's almost 100%, the model is almost 100% confident that this is a rifle. It sees a rifle. Why does it see a rifle? Why doesn't it see anything besides that? Well, we can actually, as data scientists, we can actually almost like put on the eyes of the AI and say, what are you paying attention to? And when we do that, the heat map that we see, it looks at the colors of the turtle, and it sees a hand like this. And it has learned that when I see colors that look kind of camouflage, and I see a hand like this, it's almost always a rifle. It doesn't see the turtle at all. Very interesting. So something like this is a way that we can actually test this. We can put on the goggles of the AI and say, what are you paying attention to? And see it that way. Here's an example for self-driving cars. Obviously, if you see a stop sign, you want your car to see the stop sign, stop, wait till it's safe, and then drive on. However, if you put some stickers in the perfect places, you can do a targeted attack and make it look like a 45-mile-per-hour sign to the car. So it just drives through that four-way and kills somebody, right? And you might ask, well, who's going to put stickers in that into the streets? Like, you know, you got stop signs that have lights around them to make it lighter. You have ones that are bent over or broken. You have something in the way like a bush. You got graffiti and stickers, of course you do, you know? Like, if all you have is a perfect stop sign from Amazon and you're testing it, you know, this way, of course it's always going to see the stop sign. And then someone puts a sticker on there and now sees something else. So you have the concept of untargeted attacks, where you're trying to make the AI system see anything but the right thing, and you attack it in that way. You have targeted attacks, where you try to see, instead of the right thing, you want it to see something very specifically wrong. Like, I want you to see 45 miles per hour instead of a stop sign. So untargeted and targeted attacks. In this example here, this is a security computer vision AI. I have something like this at my house right now. The person on the left is trying to, their attack is trying to have like a striped sweater that looks somewhat like the background, right? Trying to like camouflage in the background. The AI didn't get fooled, it saw it, and they silhouetted the person. However, the other guy inside, that has like a hoodie and that colorful square is completely invisible to the AI, only because he has that square on his person. That is apparently strange enough that the AI has never seen that before, and so that's not a person. They're invisible. So I'm sure that you could probably think of some interesting ways that if you were in charge of testing this computer vision model, what are some ways that you could try to fool it and trick it? At the last presentation I was at, the last conference I was at, someone from the crowd said, what if I'm like a transformer and I go like, I have like the costume and I go into a car and I go out. But perfect, you're a tester, thinking like a tester, there you go. Because sure, what would stop someone from doing that? There was some, I saw an image, an article from like the 1920s, where people that were during the Prohibition were wearing like, they had shoes on, like things that you could put on the bottom of your feet to look like cow prints. So they could go out in cow prints so they could actually sell and buy drinks and whatnot. So people will go through some crazy lengths to get around some of this stuff, right? So as a tester, we're trying to test these kinds of things. Being creative. So on the behavioral testing side of things, now we're looking at the behaviors of an AI. What capabilities does it show? So what I want to do with everyone is I'm going to throw some emojis up here. And I'm going to go 3, 2, 1, I'm going to point, and I want everyone to yell as loud as you can what movie you think this is. You ready? Here we go. 3, 2, 1. The Incredibles. I heard something not The Incredibles. The Incredibles. You got it, you got it. Okay, let's do another one. 3, 2, 1. Jurassic Park, you got it? You said Jurassic World, I guess that was World 2, right? Okay, and one more. 3, 2, 1. You guys are smarter than AI already. Yeah, you're like, wait, all these Disney movies. So you might think, why the heck is Carlos showing us this? Because we actually have open source benchmarks, open source tests that we use to test models. This one is called the Emoji Movie Benchmark, and it's part of a data set called Big Bench from Google. And it's an open source data set that we all use to help test these models. And so I think there's like 1,000 different examples that are just like this, and these 3 examples are directly from that. But we can actually say, GPT-3, how do you do against the Emoji Movie Benchmark? How accurate are you on that? Might be like 35% accurate. Cool. So GPT-4 should be at least the same or better. And now we have a baseline or a benchmark that we can compare the model to. And this is only one capability. You can imagine there's a lot of capabilities that we have. And so it's always interesting to hear people say like, well, it sucks that 1 + 1 equals 2, can't do that. Well, they probably don't care for that, I'm going to be honest. They probably don't care that it can't do 1 + 1 because there's other things that it can do. If you really wanted it to play tic-tac-toe, then you would fine-tune it to play tic-tac-toe. They're probably not going to waste their time playing tic-tac-toe. There's no tic-tac-toe benchmarks, maybe we should add that. So what does it look like? Essentially, we have to define what capabilities we want the model to have. So in this example, we're going to be doing sentiment analysis, where you see how positive or negative a sentence is, right? And so we care about things like vocabulary. How many words does the model know? Because they can't have an infinite base of words. So you have to specify which words should it have. Does it have a good vocabulary? And ER means named entity recognition. Is it good at identifying people, places, and things? And then negation. If I say, I love this, that's a positive sentence. If I say, I don't love this, this is now a negative sentence, right? So we define these capabilities that we care about, and then we come up with a bunch of test cases. And we say, for vocabulary, here's the tests I'm going to have that can test and make sure that it has a good vocabulary. Same thing with NER, same thing with the other thing that we have. However, just like we couldn't determine, or I guess guarantee, that 3 people coming into a store can spend $30, we cannot guarantee that the model is going to be perfect every single time. They're usually not that deterministic. And so instead of trying to get it 100% pipeline, a green pipeline, that doesn't exist in the AI space. Instead, we capture what we call the failure rate, where we say, of the 100 tests that you've been through for vocabulary, how many did you get right and how many did you get wrong? And we use those numbers to help us determine how good it is at that capability. So I know this is tiny, but basically you can imagine that we have all these capabilities, all of these things, and we compare 5 different models. If we zoom in a little bit more, we can see that here's 5 state-of-the-art models. One of the best ones from Microsoft, from Google, from Amazon. State-of-the-art BERT and Roberta models. BERT and Roberta are free open source ones, so of course developers and products flock to those ones because they're free. But we have this. The company is Australian. That's a neutral sentence. That is a private aircraft. That is a neutral sentence. Microsoft was perfect. Good job, Microsoft. Where BERT and Roberta, the 2 most popular, because they're free and open source, performed absolute trash. And yet they're the ones that most of the people are using because they want to use free. Very interesting. All right, I would be remiss if I didn't talk about fair, responsible AI in an AI presentation, right? So let's check it out. Back in 2017, Google wanted to create a toxicity model to determine toxicity in the internet. You can think of this for like moderators, that'd be fantastic, because that can be like in Slack or in Discord or in Stack Overflow, and I can automatically detect negative comments and flag them and let the moderators see them faster, that kind of thing. However, you can see here that the sentence, I am straight, was 4% toxic. Basically not toxic at all. But I am gay was 86% toxic. So immediately, if you were gay, you were toxic to this model. So they go, oh crap, that's not good. Well, what else could possibly go wrong? So what do? They start writing other test cases to test that capability. I am gay, I am queer, Muslim, Jewish, Christian, straight. And they quickly realize that unless you are a straight Christian, you're toxic. Well, crap, time to fine tune and time to go back to the drawing board, right? Obviously, they've made it much better since then. But you'd be surprised how many of these models have a model card that say, disclaimer, this model is probably going to be racist. This model is probably going to be sexist. So make sure you fine tune and test it yourself before you deploy to production. A lot of the model cards will say this, because they know already that it has these biases inside. This is Google Translate. Turkish doesn't have any gender in its language. For example, in Spanish we do. Right? We have niño, niña, amigo, amiga. Turkish has no gender. But you translate it to English, and immediately nurse is she, doctor is he. Showing harmful bias. And here's one more. Can anyone tell me what Casey is? Are they male, female, non-binary? What do you think? That was we have no idea. We have no idea. We don't have enough context. So if I can't, as a human, determine what Casey is, how the hell is an AI supposed to determine what Casey is? There's no way. So instead of brute forcing an AI, like an AI bias to try to make it always try to guess and try to guess right, as long as we're right 90% of the time, that's good enough. Instead of trying to force AI to do it for you, some solutions don't require AI at all. What if instead we use a UX or design solution and say, how about you determine which one is correct? We'll provide both translations, but you know the context. You pick one that works best for you. There's no AI in that at all. It's just a better user experience. All right, so with that was it. Hopefully you already see some ways that you can actually have to define. Hopefully if you have testers on your team, you can go testers. We want to test these AI systems, or you're a developer building on top of these things. Define what capabilities you want your model to have. Ask the questions. You're now seeing how easy it is for these biases to happen. Just yesterday, TII released an open source model on Hugging Face called Falcon, which has a 7 billion parameter and a 40 billion parameter model that everyone can start using right now. It's a competitor to things like ChatGPT, BART, and all that stuff. And it's now free and open source. Any of you can start building with it. These are very powerful tools, so please, I implore you, please make sure that you're testing them. You're thinking about what can it do, what can't it do. And as you make an application, you're doing it safely, and you're doing it in a way that will help everyone. Thank you very much.